Sample question paper 2024 question number 30B. Write a Python program to input an integer and display all its prime factors in descending order using a stack. For example, if the input number is 2100, the output should be 755322 because prime factorization of 2100 is 7 into 5 into 5 into 3 into 2 into 2. So how do you prime factorize a number? Let me take an example. Say n contains 60 and I want to find the prime factors of n. The first prime number is 2 and that is stored in variable d. So when you divide n with a d, whatever is the remainder is stored in variable r. So n modulo d will give you the remainder, and here the remainder is 0. So if the remainder is 0, meaning 2, in general d is a factor of n. So 2 should be pushed onto the stack. So here 2 is pushed onto the stack S. So S contains 2. If the remainder is 0, reduce n by dividing it with a d. So n is equal to n divided by d. But division operator returns the answer as a decimal number. You will get 30.0. So you can use floor division. Now there is no change in d. Continue with the same d. Again, when you divide n with a d, whatever is the remainder that you can store in variable r. So again the remainder is 0, meaning 2 is again a factor of n. So 2 should be pushed onto the stack. Stack contains 2, one more 2 will appear here. Now if the remainder is 0, reduce n by dividing it with a d. So n is equal to n floor division d. So n becomes 15 and d no change. Again, n modulo d will give you the new remainder and the new remainder is 1. So this time remainder is not 0, which means 2 is no longer a factor of n. So 2 should not be pushed onto the stack again. So no change in n. If the remainder is not 0, no change in n. Now check whether the next d is a factor of n. So how do you get the next d? D is equal to d plus 1. D becomes 3. So check whether 3 is a factor of n. So n modulo d will give you the remainder and you can store that here. So this time remainder is 0, which means 3 is a factor of n. So 3 should be pushed onto the stack. Your stack contains two elements 2 and 2. Now the third element 3 is pushed onto the stack. If the remainder is 0, n should be reduced by dividing it with a d. So n is equal to n floor division d. 15 floor division 3, it becomes 5. No change in d. Again, find the remainder. R is equal to n modulo d. What's the remainder? 2. If the remainder is not 0, meaning d is no longer a factor of n, so this 3 should not be pushed again into the stack. So if the remainder is not 0, no change in n. Check whether the next number, next d is a factor of n. So d is equal to d plus 1. D becomes 4. What is the new remainder? 5 modulo 4. The remainder is 1. You can see remainder is not 0. So what's the meaning? D is no longer a factor of n. So this d should not be pushed onto the stack. So if the remainder is not 0, no change in n. Check whether the next d is a factor of n. So d is equal to d plus 1. Now your d becomes 5. Find the remainder. So n modulo d. What is the remainder? 0. Which means this d is a factor of n. So this d should be pushed onto the stack. Stack contains 2, 2 and 3. Now 5 also pushed onto the stack. Now if the remainder is 0, reduce n by dividing it with a d. N is equal to n floor division d. So n becomes 1. And when n becomes 1, you can stop the process. Or in other words, if n is greater than 1, only then you need to carry out the process. Now from this table, let me derive the code. It's a problem connected with stack. So you can make the stack global. Special name is not given for the stack, so you can use s is equal to empty list. Now you can make the data global. So what is the data? Data is n, the number that you want to prime factorize. So n should be made global, n can be entered from the keyboard. Now the first prime number is 2, that can be stored in variable d. So d is equal to 2. Now if you perform the calculation with n, finally n will become 1. So this original number 60 is lost. So n should be stored in a temporary variable c. C is equal to n. So n is assigned it to c. So now c contains n and c should be used in calculation. So that this original number n contains 60 and it is not lost because only c will become 1. Then if c greater than 1, we need to carry out this process. So if c greater than 1, we need to do the process. What is the first step? Calculate the remainder. How do you get the remainder? R is equal to c modulo d. When you divide c with a d, remainder you can store in R. And if the remainder is 0, what is the meaning? If remainder equal to 0, what's the meaning? D is a factor of n, so d should be pushed onto the stack. So s dot append within bracket d, meaning d is pushed onto the stack. What next? C must be reduced by dividing it with a d. So c is equal to c divided by d. But division operator returns the answer as a decimal number, so use floor division. Now otherwise, if the remainder is not 0, what is to be done? No change in n. Check whether the next d is a factor of n. So next d means d is equal to d plus 1. Now if I make use of if, it will be executed only once. So if you want to repeat, see here, if I make use of if, it will be executed only once. If I want to repeat the process, if should be replaced with a while loop. Now once the use is over, the variable stack contains all the prime factors. Now display the prime factors from stack or display stack. How do you get elements one by one from stack for I? You can write a message, prime factors of n are. N will contain the original number. Now display stack s. How do you get elements one by one? For I in s, print I. But remember, if you write for I in s, the stack will be displayed from bottom to top, because left side is the bottom, right side is the top. I want the stack to be displayed from top to bottom, so s must be reversed. You can write s of colon minus 1, or you can write reversed within bracket s. So now first 5 will be printed, then 3 will be printed, then 2 will be printed, then 2 will be printed. So this is how you prime factorize a number.